will use to graph quadratic functions. But Hannah's going to start us off with number 6.
Okay, so I started off by giving all the x's to one side. So I got 2x squared minus 4x. And then I took out 2 because it's common in both of them. And then I did the equation, so negative 2 over 2 squared is 1. So 2 and then x squared minus 2x plus 1 equals 8. And I divided both sides by 2 to end up getting just that. And then I factored it to get x minus 1 squared. And then I square root each side to get rid of the square, and then I ended up with x minus 1 equals square root of 5. I added 1 to each side, so the answer was x equals 1 plus or minus square root.
Any questions for Hannah? Nice job. This one to be blue. So Reese, you have 9, right?
Yes.
Yeah. So Reese is going to go over number 9. Oh.
Hate to see it.
Alright.
Since it has a coefficient in front of it, you have to take it out, and then you do b over 2 squared, and you get 9. And then when you put it on the other side, you would get 18 over 2, which is also 9. And then you have to divide out the 2. So you get x squared plus 6x plus 9 equals 49. And then you take the square root of both of them, and you get x and 4.
Any questions on number 9? Make sure you're checking your number 9, because I see a few of you have this one incorrect. So kind of check to see maybe where you made your mistake. That one actually turns out to work out nicely for you. So just kind of take a look to see what she did versus what you have. See if you can find your mistake. Anyone have questions on number 9? So as I said, I wanted to go over number 5. So if you look at number 5, Colin, what's the first step to complete the square?
You would get rid of the minus 5x on the left side and
Yeah.
the right side.
So we'll take the 5 over by adding it, and then also what would we do?
You would pull out a 3 from 3x squared minus 6x.
Yeah, whatever the coefficient is. So that coefficient is 3, it could be 2, it could be 5, but you're just pulling out the coefficient, not the x power. Nothing with the x, just the coefficient. Because we still need something that's squared so that it's factorable. So then we need to complete the square, which Colin means the next step would be.
We would take negative 2 and we would divide by 2 and then square it.
Right. And that gives you 1. So it works out nice because there's an even number inside. As long as that number is even, you should get nice answers because you're not working with a fraction. So we would add a 1. But on the other side, we're taking 3, the number in front, times that 1. And that's to keep it equivalent. Because even though I added a 1 on the left side, anything on the left side is really being multiplied by that 3. So on the right side, we're adding 3 because 3 times 1 is 3. And then to factor it, this is now a perfect square trinomial. The 3 stays outside. This becomes x minus 1 squared, and it's equal to 8. Today we're going to stop here and look at that form and try and think about what that means with a parabola. but you were asked to solve. So if you solve, we would divide by 3. And you get, unfortunately, an evil fraction in the answer. So no, we didn't have an evil fraction to worry about when we're factoring it, but now we have an evil fraction. So taking the square root, what do you do with the square root of 8 thirds? Colin?
You'd split it up and have the square of 8 over the square root of 3.
Yeah, so think of it as separate. We've got the square root of 8 over the square root of 3. So think like 2 pieces of a fraction, get them separate, think of them separately. What do you do when you have a square root in the denominator?
So if you multiply by, like, we each multiply by the square root of 3.
Yeah, we multiply by the square root of 3. So whatever radical is in the denominator, we have to get that out when it's a numerical value. And the way you get it out is by multiplying top and bottom by that radical, by the square root of 3. So now the top is the square root of 24, and the bottom is the whole number 3. A fraction is very particular. You're not allowed to have a negative number underneath. Once we get to imaginary numbers, you're not allowed to have imaginary numbers underneath. You can't have radical numbers underneath. So fractions denominator is very specific. Pretty much the only thing that can be down there dealing with numbers are whole numbers. So whole numbers, not even 0, just whole numbers 1 through infinity. And then the last thing to simplify this, we have the 1 that we're bringing over. We've got the plus or minus. And then that square root of 24 can be broken down one more time. Hannah, what can that break down to?
The 2 square roots to go into it are 4, whole 4, and then 6. Then you can square root 4, so it'll be 2 square root of 6.
Nice job. So there are a couple of things that you had to recall from last year about radicals with that problem. So you had to rationalize the denominator, that's what the process is called to get the square root out. And then, because you have the square root of 24 on the top, that can be simplified. There are 2 values that divide into it, the 4 is the perfect square. Questions? So today we are going to use this process, and we're going to talk about quadratics, which was the first chapter of Algebra 2 last year, because really Algebra 2, chapters 1, 2, and 3 were a review of Algebra 1. But a little sprinkle of new stuff. It's kind of similar to this, but it's a lot of new stuff. But today, talking about parabolas, it is going to be review, but then trying to get it in that form with completing the square. So the whole chapter focuses on polynomials and rational functions. And a polynomial has a bunch of powers. So it's a function involving powers that descend in order. Don't get squeamish about the notation up there. Yes, it looks crazy. But it just shows you that your powers of x should go down by 1 each time. That's what that n minus 1 means. So your biggest power, your second largest power, and then they descend in order. The last thing should be the constant. That's why it has a 0 with it, because it really is just going to be a constant. It doesn't have an x term with it. So again, that's just the form of a polynomial showing your powers descend in order. In the little chart, it kind of shows you how equations build off of each other. So we have the name of the function, the equation, and then what the graph would look like. But back in Algebra 1, or maybe even pre-algebra, when you were starting to be introduced to types of graphs, each graph builds on the previous graph, or each function builds on the previous function. So the first one is our constant function, which could just be y equals 3. So that's the most basic, my line. It's constant. Y equals 3, y equals 10, y equals 15. It's a horizontal line. And then when we start adding variables, that equation or graph gets a little more interesting. So this is our mx plus b form, but keeping consistent with the a, you can see that adding or multiplying that a by an x, and then adding that b gets us a new graph, because now I have numbers we can plug in for x that change the height of the y, so that gets us our straight line. And then if I continue to place an extra power in there, so now with my a I have x squared, and then I have the bx, and then the plus c, I now have a parabola. So building on that first term, making it an extra power, gives us more curves in the graph. So I could continue with a cubic graph having ax cubed plus bx squared plus cx plus d. And essentially you're just adding an extra letter once you add an extra power. So functions build on one another. And that's really how a function is created. And then after we run out of powers, then we start flipping them and making them like fractional powers or making fractional equations. So we have two different cases here of a parabola. The first case is when the number in front, the a value, is bigger than 0, and it says the vertex is a minimum. So that would be the traditional parabola, y equals x squared, the a being positive. So we know that's our graph that opens up, which is why we say the vertex is a minimum. So draw a little parabola opening up. That's our smiley face parabola. Happy it's Friday. So a positive parabola opens up. It's happy. Its vertex, which is the point right here, that's called the minimum. Now it has a little dimple in its chin. The other option would be when our a value is less than 0, so any negative number in front of the x squared. Then our parabola goes down, and it makes a frown. That's how it's going to feel on Monday morning. Yeah, and that vertex is called a max because it's at the highest point. So if it goes down, it makes a frown, but the highest point in the graph is a max. So down max, up min. Every graph that goes up, you have a minimum. Every graph that goes down is a maximum vertex. So we're going to talk or review about how to find that information. So how do we get a vertex? And there's another part of a parabola that we're also going to find, and that's the axis of symmetry. Does anybody remember what an axis of symmetry is? Going back to my little picture here. What is an axis of symmetry? Brendan, what is an axis of symmetry?
It's where like one part of the graph will reflect over the other.
Yeah, so where that graph, the one part is going to reflect over the other. Usually we say that is the line that goes through the middle of the graph. It splits the parabola in half. One side is symmetrical to the other. So we draw it usually as a dashed or a dotted line going through the vertex. Always passes through the vertex. So the axis of symmetry, get rid of this picture, doesn't want to go away. Here we go. Is a line that splits the parabola in half. And it'll always pass through the vertex. Our axis of symmetry is a vertical line. And because it's a vertical line, it is going to be in the form x equals something. So, thinking in your brain, question of the day. There is a little formula about how we calculate the axis of symmetry. It's a fraction. Does anybody remember how to calculate the axis of symmetry? And going back to that equation, I don't know why I have so many stinking pages here. Let me get rid of them. So going back to your little chart and looking at that equation, that ax squared plus bx plus c. That equation helps us find the axis of symmetry. Does anybody remember how you find that? The little formula. So it's negative b divided divided by 2a. You will need this formula for the last 2 problems of your homework. The other problems, we're going to do a different way. But those last 2 problems, you'll need this. So put a little star next to it, remind yourself that there are 2 different ways I can find the axis of symmetry. This is the one way when I have the form ax squared plus bx plus c. That is called the general form of our parabola. What we're going to do today is take that general form, do a little bit of completing the square to get it into standard form. So completing the square gets us into a form that we can graph pretty easily. So that's why we use completing the square. So standard form is also known as graphing form. And you can kind of see the difference. There's still an a, but now I have this quantity that's squared. And now we also have that h and the k, which tells us how the graph shifts. And that h and the k were in all of the graphs that we have looked at in chapter P and chapter 1. So it moves left or right, it moves up or down. Our vertex would be the h and k values. So when it's in standard form, because we completed the square, the numbers in the equation are the vertex. Whereas if I have general form, I have to calculate the vertex using negative b divided by 2a, or calculate the axis of symmetry. The axis of symmetry when it's in this form is just h, because the x of the vertex and the x value of the axis of symmetry, the symmetry passes through the vertex, so they share that x value. So we can find the axis of symmetry 2 different ways. I can find it because I've completed the square and I'm looking at the h value, or I can find it by using this equation. And sometimes it just depends on what types of numbers you have, why you would use one form versus the other. Because sometimes completing the square doesn't work very nicely. So then we kind of revert back to just using negative b divided by 2a. So if you flip and look at the top of the next page, you're going to have 5 problems tonight. 17, 25, 29, 31, 35, maybe 6, maybe 39 as well. No, 39 separate. 17 to 35, those handful of problems, 5 different problems, where it's going to be like example 1 and example 2 that we do together. There are specific directions written on the assignment sheet. Please follow those directions. Essentially, you're going to be finding these pieces of information that we're going to go through. So we have 4x squared minus 4x plus 21. That's a quadratic function. It has x squared. Our goal is to get it into standard form, and we're going to use completing the square to do that. And I just write CTS, complete the square. So instead of using the current form, which is general form, we're going to change this so that we can get it into this graphing form. There's a couple things that we need to do in order to help complete the square. The first thing, we have to take this f of x and make it 0, so that we can start moving the term to the other side. And now we're going to complete the square. So this 21, I'm going to move to the other side. If you don't like that it's on the left, you can move it to the right, because you always like doing that. It's up to you what side you want to take it on. And then after you move the 21, what else would you do to the problem? Hannah? Take out a 4. So let's do that in the same step, pull out a 4. So that leaves us with x squared minus, unfortunately, a 1. And then the x. So Hannah, the next thing that you would do,
Plug it into equation, so negative 1 over 2 squared.
right, negative 1 over 2 squared, square the top, square the bottom. What does that become?
1 over 4.
Right, that becomes 1 over 4. So I know you're thinking, oh my gosh, this looks horrible because we have a 1/4 there. Well, when you multiply the 4 times 1/4, what is 4 times 1/4? 1. So on the other side, we're just adding a 1. So it's not too bad. Yeah, we've got a 1/4 in there, but at least on the other side we added a nice number of 1. So my left side now says negative 20. The right side has the 4. And then how does it factor in parentheses? Hannah? x minus a half. So our goal is to get this into standard form. We're not doing anything else from this point besides just rewriting it. Standard form takes us back into that function form, so f of x. And then I need a times x minus h squared. Well, I have a, which is 4. X minus h squared is x minus 1/2. And then the negative 20 goes back on the other side. So this is standard form. So we completed the square, and then we just move the number back to the other side. So that you have a x minus h squared plus k. So started with general form. That's the most common form that you would have thought of last year. And now we have it in this standard form. Questions? So part B wants you to find the axis of symmetry, which I just call AOS, and then it asks you to find the vertex. You don't need to do any other calculations because you've already done the work. So now that you have the work, Carrie, what would the axis of symmetry be? So what letter is the axis of symmetry in the problem?
H.
H. So here's A, x minus h, and here's k. So it's a half. So this number right here is your axis of symmetry. Whatever number's in the parentheses, that's h. And then carry the vertex would be
1/2 20.
1/2 and 20. Because the vertex is h and k. So after you do the work completing the square, the axis of symmetry is the number with x because that tells us where we're moving left or right to get to that middle of the graph. The vertex would be the value, 2 values inside and outside. The last part says find the x-intercepts. How do you find an x-intercept? What do you usually do to get an x-intercept? Carrie?
Make y equals 0.
You make y equals 0. So if I go back up here with my work, and it's kind of like got squished together, if I go back to this equation here, my y is becoming 0, which I actually did at the top as well, just to kind of get us to complete the square. So if my y is 0, we are now going to solve for the x-intercepts, and that's what you did on the worksheet. So in the completing of the square worksheet, you were finding the x-intercepts. You were solving for x. Anytime you solve for x graphically, that's an x-intercept. So I could take the 20 to the other side. Reese, what else would we do to solve for x?
You could do all of them different.
Yeah, so get rid of the 4. And then, Reese, you would take the square root. What happens? Emily, do you know what happens? What happens with the square root of negative 5? You can't take the square root of negative 5. What does that mean about your x-intercepts? There aren't any. You can't do that. You can't take the square root of a negative number. It doesn't exist. So that means that the x-intercepts do not exist. Does anybody know why the x-intercepts do not exist? So think about the vertex. Where is the vertex located? Where is 1/2 20? Carrie?
It's above the x-axis.
It's above the x-axis, and this is a graph that's a happy graph. It has a positive number in front. So there aren't any x-intercepts because the graph starts way above the x-axis. And because it's starting above the x-axis, it's never crossing it. So that's why there's not an x-intercept. Questions? So I need you to start pulling together, what does this stuff mean graphically? How does that correspond? So thinking there aren't any x-intercepts because the graph starts above it. They go together, the vertex and the x-intercepts. Questions? So we're going to do this problem again, just different numbers, but trying to work through the same information. This is what the assignment sheet asks you to do, these steps here. So the vertex, axis of symmetry, the intercepts, and then the direction of the parabola. In order to find all of that, we're going to complete the square. So see if you can take this problem, just change f of x to 0. And think about that process of completing the square, because that's what we're going to use to help us get the vertex, the axis of symmetry, the intercepts. The direction of the parabola, we can use the current information, and use that information to in the completing the square. So move the number over first. And then is there anything that we have to factor out? Lauren, is there anything that needs factored out?
A negative.
A negative, yeah. It has to be a 1 in front of x squared. It cannot be a negative, so we'll take out that negative. That makes it x squared plus 4x because we pulled the negative out. And then, Lauren, if we do b divided by 2 and square it, you get 4. What number do you place on the other side? I didn't make space. Yeah. So on the other side, even though we plugged in a 4, that negative is sitting out front, and that's the tricky part. So we're actually putting a negative 4 on the other side. So that makes a negative 5 x plus 2. So we have the negative, we've got an x plus 2, and then a positive 5. So completing the square takes it from general form, and it places it into this vertex or standard form. Any questions with completing the square? So see if you can answer the couple of questions underneath. So now that we've completed the square, what would the vertex be? What would the axis of symmetry be? We're going to find the y-intercept as well. Oh, it said intercepts up there. I thought it just said x. No, that's my fault. Yeah, we're going to find the y-intercept as well. Thanks. I was leaving that out. So Garrett, the vertex would be
Negative 2, 5.
good, negative 2, 5, and then the axis of symmetry
Just negative 2.
is just negative 2. So to find the x-intercepts, go back to your equation, and x-intercept is found when y is 0. So that means I would have to take the 5 back to the other side. And then Garrett, what would we do to solve for x?
First you divide the negative 1 time.
Yeah, so that's how this becomes positive. And then,
Take the square root of both.
so your answer would be
X. X minus 2 plus or minus square root of 5.
So taking the square root of both sides, moving the 2 so that it's with the square root of 5, I have to subtract it. So since it's an intercept, I'm going to just cheat here, write it as an ordered pair. And an intercept occurs when the y value is 0. It's a point on the graph, or 2 points on the graph. So Josh was kind enough to remind me that I skipped the y-intercept because there are 2 types of intercepts, not just x, but there's also y. And we find a y-intercept by letting x equal 0. Without doing any work, where could you find a y-intercept? No work. I don't want you to do any work. Learn. The starting problem. So if you go back to the starting problem, if I make x 0, Lauren, what's the y-intercept? A 1. This guy right here is your y-intercept if you go back to the starting point. Because if x is 0, my x squared is gone, my 4x is gone. So that last number will always be your y-intercept if you go back to that original problem. So the y-intercept is that last little piece of the problem. It's the c value. The last question here says determine the direction of the parabola. Colin, what direction does this parabola go?
It's like down.
So it goes down because it's negative. So the direction of the parabola will be going down. If it asked, the vertex is a max. Questions? So completing the square takes an equation and it gets it into a different form. That other form then gives us information about the graph. So by using this form, I can see the vertex, I could see the axis of symmetry. We can solve for the x-intercepts pretty easily by taking the square root of both sides. Questions? So the next problem on here, and then I think there's two graphs, yeah. One says to kind of do the opposite. So it gives us information about the graph. And it says we want to find a quadratic function that has a vertex at negative 2, 2. So now we know the vertex, but we don't know the equation that goes along with it. And it's going to go through the point negative 1, 0, which happens to be one of the x-intercepts since the y value is 0. That part doesn't matter, that's an x-intercept. It just could be a random point on the graph. How do you think you could find a function, Colin?
You would plug in the ones for which you know. So you would plug in -2 for h, 2 for k, -1 for x, and 0 for y.
Nice job. So those are the pieces of information we know. If we can just label them with what they represent and go to that same equation that we use completing the square for. So y equals a x minus h squared plus k. So that is our standard form that we would get by completing the square. And then he said plug in everything you know. So y is 0. I don't know a. X is -1. H is -2, but when you plug it in, it becomes a +2. And then k is 2. So be careful because it's already a negative going in place of a negative. So the missing piece that we don't know is A. We don't know how wide the parabola is. And that's what we're going to try and find out. How wide is this parabola? Order of operations. Parentheses go first. This is now 1 squared. That 1 is attached with A, so that's really saying I have 1A and then +2. Don't add those two numbers together. The 1 is attached with A, it's being multiplied with A. The 2 is separate. So if I solve for A, Josh, A is -2. Buddy? There we go. So A is -2. So the equation of our parabola, now that we found A, we would plug in the -2. You're only using your H and K. So H and then K. Lots of 2's. That would be our standard, or I'm sorry, our equation of the parabola in standard form. So I would say this parabola goes down because it's negative. It has a vertical stretch of 2, thinking about that information from chapter 1. My vertex is going left 2 and up 2. So that would be like the translation of the graph, going down, stretching, moving left and moving up. Questions? The last 2 problems on there ask you to graph the function. So kind of knowing what we have from the last chapter, knowing what we just talked about, make just a little sketch, a little tick mark on there, x and y axis. So Dylan, how does the first graph move? How's it translate, transform? So it goes up 1,
Is reflected over the x-axis.
and it's reflected over the x-axis. So the negative reflects it, it makes it go down. The plus 1 is moving its vertex up 1. So it's a standard equation, but going down. So if I move over 1, I go down 1. 1 squared is still 1. If I go over 2, 2 squared is 4, so I need to move down 4. So I have a parabola that goes down. 1 over 1 squared is 1. If I move 2 over, I'm squaring it and I'm moving down 4 because 2 squared is 4. And then, Gabby, how about the letter B? How's that one moving?
The vertex would be -2, -3, and it would be
Yeah, so vertex is -2, -3, so we're moving in that direction. -2, down 3. This graph is going up. So from the vertex, over 1, 1 squared is 1. If I go over 2, 2 squared is 4. And then we have a parabola. So completing the square helps us get a form of a parabola that's easily graphed. Questions? All right, so homework tonight, 5 problems that are like this. Again, follow the directions on the assignment sheet. Essentially, you're doing this stuff right here. So you're completing the square, you're finding the vertex, axis of symmetry, and the intercepts. Then you're gonna have a couple problems, I think 2 problems, that you're plugging in the vertex and the point, and you're finding the equation. The last 2 problems are where you're gonna have to use that negative b divided by 2a. Because completing the square is going to be a pretty difficult process to do for those last 2 problems. Because some pretty large numbers in front for the coefficients. Anybody interested in doing 35 or 65? Emma, 35, 65? Yeah?